We're going to continue calculus topic 5.1, mean value theorem. We're going to be looking at example 6, and we're going to actually go through the entire problem this time, not just identifying IVT or MVT. So in this one, it says the function is differentiable for all values of x. That's good. Selected values of g of x are given in a table. Is there a time such that g prime, this should say g prime of c equals 2? I have g and g prime, so that means since they're mismatched like that, we are doing MVTs because we know it has to be an MVT problem. We know the answer to the question is yes, yes, there is a time. So yes, g is differentiable. We're starting just the same way we did before, differentiable, which implies that it's continuous. On the interval from 0 to 6. And then we want to say the mean value theorem. So we could say, therefore, the mean value theorem guarantees that there is a time, and in this case, they used the letter C, so we're going to use C, between 0 and 6, such that, and then I want to actually show the calculation for that value right there. G prime of C, so the instantaneous rate of change, I want to show that I know that it is G of, and I'm going to use this interval, G of 6 minus G of 0 over 6 minus 0, and I'm going to actually do the work. So I would say 10 minus negative 2 over, so we know that it's just going to be 6. So it's 12 over 6 equals 2, so which is what they wanted us to show. And let's look at example 7. So in example 7, this is the function f prime is differentiable for all values of x. Selected values of f prime are given in the table. Can you guarantee a time k between 2 and 15 such that f prime of k equals 5? Give a reason for your answer. Notice it's in derivative to trick you, but they're both derivatives, so we know because they match that that's IVT. So can you guarantee? Yes, we can guarantee that. So yes, f prime is differentiable, which implies that it's continuous. Therefore, the little 3 little dots is therefore IVT guarantees that there is a time k between 2 and 15 such that, okay, so I really need to actually look at this. So I'm going to do some work off to the side really quick now that I've got that. I'm going to look at what f prime of 15 is and what f prime of 2 is. I need to look at that to make sure that this number is actually in between it. So f prime of 15 says it's 6, and f prime of 2 says it's 1. So it does for sure look like that 5 has to be somewhere between 2 and 1. So I'm actually confident in writing this statement, so such that f prime of k equals 5. All right, let's take a look at example 8. So in example 8, it says between 0 and 8 hours, the rate that people leave the museum can be modeled by the differentiable function L prime of t, where L prime is measured in people per hour. Selected values of L prime of t are shown above. Do the data in the table support the idea that L double prime of C is equal to 0 for some value of C where between 0 and 8? Give a reason for your answer. So notice I'm mismatched. I've got first derivative and second derivative. So since I'm mismatched, I have MVT this time. The answer is always yes. So yes. And you start by saying L prime of t is differentiable, which implies that it's continuous. And then we're going to say, therefore, MVT guarantees that there is a time, and this time they're saying that it's C. There is a time C between 0 and 8 such that, okay, it says we want second derivative. So L double prime of C equals, I'm going to do my slope calculation now. So L prime of 8 minus L prime of 0 over 8 minus 0 equals, so now I'm looking at these values right here. So it's 6 minus 6, right? Those are my y values, over 8, which is going to be 0, over 8, which is going to be 0.